The complex numbers Z and W are such that Z equals to 1 plus IA, that is equals to negative B minus I, where A and B are real and positive. Given that ZW equals to 6 minus 11I, I want to find the exact values of A and B. Okay, so one thing good is that we know that A and B are real and positive. Alright, so we want to find the values of A and B. Okay, first up, so looking at A, we know that ZW, right, the product of ZW is just the same as 1 plus IA multiplied with negative B minus I. Okay, so if I go on and expand this, I'll get like negative B minus I minus A IAB plus A, right, equals to 6 minus right, and this is equals to actually if I group the imaginary and real parts together, it's the real part plus 1 minus 1 minus ABI. Okay, right, and we also know that this, given that this is equals to 6 minus 11I, so you know that A minus B plus I of negative 1 minus AB, this is equals to 6 minus 11I. Okay, so we know that A and B are both real and positive, so if we compare we can actually equate the real and the imaginary parts. This is the equality of the real and imaginary, so we can say that A minus B is equals to 6 and negative 1 minus AB is equals to negative 11, or simply put 1 plus AB is equals to 11. Okay, can okay, next, then after that 1, what we do is now we do substitution. Okay, so from 1 you can say that B is equals to A minus 6. Alright, and then sub 3 into equation 2, and 1 plus A, B is A minus 6, then will equal to 11. However, A square minus 6A minus 10 to be equals to 0. Then from here, I try to solve and find the value of A. So I realize that cannot factorize, cannot, okay, most what I do, maybe I can copy a square, alright, or I can use the quadratic formula. Okay, so I'm lazy, so I'll just use the quadratic formula. 6 plus minus AB square. A is 6, B is negative 6, so it's B square is 36 minus 4 AC, right, then over 2A, right, so the answer will just turn out to be 3 plus minus square root 19. Okay, but we know that A is positive, right, so since A is positive, because in the question they tell you, since A is positive, A should be equals to 3 plus square root 19, right? Then next, part B, okay, we haven't found B yet. Okay, after that, let's find B. We know that B is equals to A minus 6, right? So it's equals to 3 plus square root 19 minus 6 equals to square root 19 minus 3. And that's our B, right? So that's for part A. Part B, we are looking at the conjugate of a number. The conjugate of a number has modulus 2, argument 2 over 3 pi. V has modulus 5, argument 3 over 4 pi. Now we want to find the exact values of the modulus and argument of V over U square. Right? So V over U square, simply, right, we can conclude, let's say, just summarize, modulus equals to argument of U equals to negative 2 over 3 pi. Mod of V is equals to 5. Argument of V is equals to 3 over 4 pi. Right? And let's find what's the modulus of V over U square. The modulus of a quotient is the same as the quotient of the modulus. Right? So this will just give us 5 on the top. At the bottom it will be 2 square. And the answer turns out to be 5 over 4. And as for the argument of V over U square, this is the same as the argument of V minus the argument of U square, or the argument of V minus the 2 times the argument of U which is equals to 3 over 4 pi. Okay, subtracting negative 2 over 3, 2 times of negative 2 over 3 pi, which is equals to 25 over 12 pi. Right, but 25 over 12, you know that it's not within the principal range, so minus 2 pi is too big, so answer is just pi over 12. Okay, this is the argument of v over u square. Alright, what about, okay, yeah, with that we are done. Right, we have found two answers. Right, so next up, find the smallest positive integer such that the point representing v over u square to the power of n lies on the negative imaginary real axis. Okay, real axis. Okay, so v over u square, we can write this because we have found the modulus and the argument of v over u square. You can say it looks something like this. Right? Okay, okay? Right, and we just want it to be imaginary. It means that the real part is 0 and yes, we okay. So imaginary axis also mean one thing. Right? Imaginary axis, negative imaginary axis also means that, right, my argument is equal to like negative pi over 2. Right? So I can say that if I want this to be imaginary, I can say this portion must be equals to like a negative pi over 2 or negative pi over 2 plus some multiple of 2 pi, example, right, where k is okay, yeah, where k is positive, okay, it's an integer. So the thing is, yeah, I can say this because negative imaginary means it lies on negative imaginary axis. That means I'm saying that sine of m pi over 12 can be written like this, right? I'm not wrong to say that, right? Okay, so with that, if you actually sorry, I shouldn't say that. Yeah, so with that, right, okay, so n, if I simplify, taking away pi and 12, n is just equals to negative 6 plus 24k. Okay, and if I want to get the smallest possible value of n, smallest possible value, maybe what I can do is maybe I just let this, I can't let it be 0, right? That'll be n be negative. Maybe I just say let k equals to 1. That's the smallest possible value of n I can get. N is just equals to negative 6 plus 24, which will be equals to 80.